Hi guys, welcome back for lesson 1-2, two variable equations. So our targets today, we're going to be creating an equation with two variables to talk about relationships between the two. And then we're also going to be graphing these equations. So what we're going to need today is you're going to need your Springboard book, pen or pencil, and a calculator handy for some quick calculations if you need it. So let's get started here. So we're on page 7 in your book, and we're going to talk about this Sapphire Island. So since we didn't do 1-1 in our book, we don't really have all the context of this water park, Sapphire Island, that they're talking about here, but we'll get there. Okay, so at Sapphire Island, visitors can rent inner tubes to use in several of the park's rides and pools. Maria works at the rental booth and is preparing materials so that visitors and employees can understand the pricing of the tubes. Renting a tube costs a flat fee of $5 and an additional $2 per hour. Now, in all that whole paragraph, there really wasn't much that was important besides this last sentence. Renting a tube costs a flat fee of $5 plus an additional $2 per hour. So remember, a flat fee, you pay it once, $2 per hour, that's going to change things. All right, so keep that there. Maria started making a table that relates the number of hours a tube is rented to the cost of renting the tube. So use the information above, probably what I highlighted for us, right? To figure out this table, okay? So if we rent this tube for 1 hour, so there's that flat fee of $5 no matter what. And then it's $2 for every hour we rent. Well, if we only rent it for 1 hour, that's $2. We didn't have to charge any more, right? So our total cost would be $7. So I'm going to have you guys do is finish the rest of this table. So go ahead and fill in what would be the price if we rented it for 2, 3, 4, or 5 hours. So pause the video here and go ahead and fill that in. Okay. So if you filled in the table correctly, it should look something like this now. Okay, so 2 hours would cost $9, 3 hours $11, 4 hours $13, 5 hours are $15. So explain how a customer can use the pattern to determine the cost of renting the tube for 6 hours. Well, you can continue the pattern if you see one, or it would just be $5 plus $2 per hour, right? It'd be the same thing as the rest of the table that you already did. All right? All right, so now we're going to get into some vocab here. Maria wants to write an equation in two variables, x and y, that employees can use to calculate the cost of renting a tube for any number of hours. Okay, so Maria wants to make it easy for her employees. They say, I want to rent a tube for 10 hours, 8 hours, 3.5 hours. They can calculate this for her, okay? So what does the independent variable x represent in this situation? So an independent variable determines the value of the dependent variable. So think of independent and dependent kind of like cause and effect. So if I go back up to this table here, we have hours rented and costs. So one of those is independent and one of those is dependent. So the independent variable determines the value of the dependent. So in this case, I would kind of consider the independent variable to be the hours rented. Because the hours we rent it depends on how much money we spend, right? So if we talk about what does the independent variable x represent in this situation, it's the hours rented for the tubing, okay? Because however long we rent the tube for, that's going to change our cost, okay? So that leads us to the next question here. What's the dependent variable y represent? So the dependent means it's dependent on how many hours we rent. So the y value represents the cost, how much money we spent at our water park. All right, so here's the whole point of this problem. They want us to write an equation to represent this situation. So the flat fee of $5, and remember, it's $2 per hour. Okay, so, and that is going to have to equal the cost. So I'm going to have you guys try it to write the equation that models this situation. So you're going to have two variables, y and x. So give it a try, see what you get. Okay, so here we go. Here's our equation. So y equals 2x plus 5. So again, y is the cost. So we know the cost equals $2 per hour. So that's one that's going to be the independent variable. It's going to be changing every time. And then again, your flat fee of $5. You pay it once and that's it. Okay, we're going to skip 6 and 7 just for the sake of remote learning so we can kind of move on a little quicker. Okay, so Marie is going to find it useful to make a graph of this equation that relates to the time in hours a tube is rented and the cost in dollars of renting a tube. So list 5 ordered pairs that lie on the graph of this relationship between x and y. So we have, remember, y equals, we said 2x plus 5. That's our equation. $2 per hour plus the flat fee of $5 equals our cost. Now, you could graph this in your calculator and get ordered pairs from the table, or what I did is I just recopied our table from the first page. Make our lives a little easier here. And so I don't have to keep flipping back and forth between slides. So if I think of this as 1 hour rented costs $7, well, there's your x variable and your y variable. So this table actually gives us ordered pairs. So we don't have to keep rewriting them or making up new ones. We'll just use these. So we have 1, 7. We have 2, 9. 3, 11. 4, 13. And 5, 15. So we have our x, y. Okay. So what we're going to do next on the next page then is we're going to graph those ordered pairs and make a visual representation of this scenario. So use the grid below to complete parts A and B. So write an appropriate title for the graph based on the real world situation. Well, I'm probably just going to use what we have on our table here. They're calling it tube rentals. So why don't we just use that? And then graph the ordered pairs that we listed in number 8. So go back to your problems on number 8, and then go ahead and plot those points on the graph. Then connect the points with a line or a smooth curve. So take a minute and plot those points. We're going to pause the video here and have you guys do that. Okay. So if you plotted the points that we had, it should have a graph that looks something like this. So there's my 1, 7, 2, 9, 3, 11. Okay. And then it looks like it connects with a straight line. There's not a curve to it. So we're going to use this graph now, and we're going to answer those bottom questions. So I want you guys to actually just answer these on your own and check back for the answer. But number 10, we have, based on the graph, I'm going to try to keep the graph in the picture here. Explain how you know whether the equation models the situation is or is not a linear equation. So think about linear from Algebra 1. What made something linear? So do you think that this graph here is showing a linear equation? So I have that, yes, it is linear. So if you look at it, the key word we want to see is this constant rate of change. So no matter what we think of the graph, if you remember rise over run from Algebra 1, it has the same rise, the same run every time, up 2 over 2, up 2 over 2. Well, it's technically going up by 1 since these are going up by halves, but you get the idea. So you know if something's linear if the graph has what we call a constant rate of change. Okay, so there's no curve. One point doesn't go up more than the other ones. It's all constant and consistent. Okay, question 11. Explain why the graph is only in the first quadrant. So remember, normally a graph has 4 quadrants, right? I'll just draw a quick graph really quick. So you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now they're saying that this graph that we have is only in this first quadrant. So they want you to answer, well, why is that? Okay, So if we think about this in terms of what we're talking about, we have a tube rental. So remember, X was the number of hours we were renting it for, and Y was the cost, Y. So the reason we're only in the first quadrant here is because you can't have negative values for either of those variables. We can't go back in time, so we can't have negative hours, and we're not going to charge somebody a negative amount because that's not a good business plan, right? Then it means we're giving away money. So that's why we're only in quadrant 1. All right, what is the y-intercept of the graph? And explain what this means in the context. So let me go back up to the graph here. So I have the y-intercept graphed on mine because I continued the pattern. So what is that y-intercept and what does it represent for our tube rental scenario? Okay, so the $5 is our y-intercept. That's where it crosses the y-axis. And that represents our flat fee. So if you didn't rent the tube for any hours, you would still have to pay that flat fee of $5 because no matter how many hours you ride the tubes for, you still have to pay the $5. And then last question we're going to do today, what is the slope of the graph? And describe what that just means in this situation. So looking at our graph here, look at what the slope is. Remember, slope is rise. How much does it go up? Vertical change over the run, the horizontal change. And just be careful because these tick marks are going up by half. So it's 1, 1.5, 2. So think about what's your rise over run. So figure out the slope and interpret it for our tube rental scenario. Okay. All right, so we should have got that their slope should have been 2. It was up $2 and over 1 hour. Okay, and that's the amount that the graph increases per hour. So again, we could also look at the equation that we had, the y equals 2x plus 5. Now this equation is in slope-intercept form. So 5 is your y-intercept, right? And 2 represents the slope. So in the context, it's $2 per hour. That's how much the price is rising for every hour. $5 is your initial value, that flat fee. Okay. So that is the end of lesson 1-2. Okay. So we didn't really write too many equations today, just the one, but we're thinking of it in terms of y equals mx plus b, that's slope-intercept form. So you have your two variables, your x, your independent variable. How does that affect your y? In the end, your dependent variable. Okay. All right, guys, I'll see you for the next lesson. Have a great day.